All right, we're looking at the Lesson 7 practice problems from Unit 4 of Algebra 1, Illustrative Mathematics by Imagine Learning. It starts on page 182 of your student workbook with number 1. The temperature was recorded at several times during the day. Function T gives the temperature in degrees in n hours since midnight. So again, the starting time, this 0, is actually midnight. And then everything on this graph is like 1 a.m., 2 a.m., 3 a.m. See how they have a little 5 here? That would be 5 a.m., 10 a.m., etc. So it's going hours since midnight. So this little line right here, see how that's halfway between midnight and 5 a.m.? That's like 2:30 a.m. or 2.5 hours since midnight. And it's asking us to look at the interval from n equals 1 to 5. Well, your time of day is your n axis. And so from 1 to 5 is really going from somewhere like right here to right here. And so when we're looking at this little dots, what are they doing on that interval? We're going like this. And so is that positive change, negative change, or a zero change for the average rate of change? And so we see that it starts high and goes down low. So of course we would just call that a negative average rate of change. Next it wants from 5 till 7. So again, we go look at this interval and we're starting here at 5 and just going till 7. And even though there's really only 2 dots there, we see that the second dot is higher. So even though it's small, it is still a positive. How about from 10 to 20? Now we're starting here at 10 and we're ending here at 20. Now, even though in between it goes up and then down, from the first point to the second point, our average rate of change is still going up. So again, this one would be a positive. Even though it went up and down, its overall change is up. From 15 to 18, well, that's going to be like right here and right here. And so from 15 to 18, looking at those 3 dots, they kind of look like they start and end in the same place. Would you agree? So I'm going to say that that is a zero change, where it starts and stops at the same spot. Finally, we're going from 20 to 24. And that one is definitely a negative. Okay, next we're looking at a graph that says it's showing the total distance in feet walked by a person as a function of seconds. Was the person walking faster between 20 and 40? So down here we're looking between 20 and 40 along this axis. And is that faster or between 80 and 100? Well, between 80 and 100, it goes up higher. Than here to here. And notice it's still an interval of 20 seconds for each. And so since the interval or the denominator is the same, we're really just looking at which one is steeper. And so what would you say? Which one is going faster? You got it. It's the 80 to 100 second interval. So you're going to write or type a full sentence saying that between 80 and 100 seconds, they were going faster because the line is steeper. You could actually calculate an average rate of change and give an actual number, etc. Was the person walking faster between 0 and 40? or 40 and 100. So this one from 0 to 40 is on a 40-second interval. And then from 40 to 100, it's on a 60-second interval. So this time the denominators are different, so we can't just look at what's steeper. So this goes up by 10 on that 40-second interval. So remember, our average rate of change is the change in y over the change in x, also known as our slope formula. So we're getting an average rate of change from 0 to 40 as 1/4 or 0.25. Then looking at the other change, this one is also going up 10, but it's on a 60-second interval. So the change in y over the change in x, or the average rate of change, is 0.17 versus 0.25. So which one is greater? Still the 0 to 40 seconds. Is a greater average rate of change, is where they're walking faster, etc. Number 3 is a matching. I'll do one with you and you can do the rest. When is the average rate of change negative? We're talking about a squirrel running up a tree. And so if the squirrel runs up the tree very fast, if the squirrel starts and ends at the same height, if the squirrel runs down the tree, if the squirrel runs up the tree slowly, which of those statements matches with the average rate of change is negative? You got it. It's when the squirrel is running down the tree. So how do you want to show that? Do you want to just draw a line to it? This is 1, this is C, something like that. Go ahead and match the rest. The percent of voters between age 18 and 29 that participated in an election between 1988 to 2016. Function P gives the percent of voters and participated in the election in year T. So remember that when you've got a table that's horizontal like this, your inputs or your X values are on the top. And your Y's or outputs or f of x is along the bottom. So determining the average rate of change between 1992 and 2000, we're looking at this interval right here. And so again, we've been talking in this chapter about slope formula, but now we're talking for average rate of change, which is talking about the change in y over the change in x, like the slope formula, but we are talking about functions. And so this average rate of change formula from the summary was given to us as the output of B minus the output of A over the input for B minus the input for A. So again, this is the function notation for average rate of change instead of the slope formula using x1s and y1s, etc. So where are these values up here on this interval? Well, when we're subtracting the outputs, we're talking about f of B being this second term minus f of A. Those are the two outputs. And then this inputs 2000 minus 1992. So here we go plugging in 34.5 minus 42.7 over 2000 minus 1992. So take a minute to grab your calculator and do 35.7 minus 35, okay, you can see it. 34.5 minus 42.7 negative 8.2 divided by 8 gives me an average rate of change is negative 1.025. So that means right here, over this interval, we see a drop. Notice it goes down. Now pick two different values that have a negative average rate of change, just like with the one we just did. And so pick any values where you see a drop. Like right here, this interval, 48 drops down to 40. Or this interval 45 drops down to 40. So if you want to do this interval, go for it. But you can pick different values than someone else in class because you just need to find a drop. You're going to apply the same formula and subtract the outputs over the inputs minus the input. So now pick two values where the positive average rate of change happens. And so if I look at the starting point, 35.7, and the ending point, 43.4, that average rate of change is going to be positive. So I could just do the whole interval if I wanted for that last one. But you go pick and then subtract the outputs over the inputs and see how it goes. Next, what does d of 10 equals 0 mean? And we're talking about the function d gives the distance from school in meters and as a function of time in minutes. So t is 10 minutes and distance is 0 in this scenario. So you would write up a sentence that says, well, if my distance from school after 10 minutes is 0, what does that mean? It means I got to school. So I arrived to school after 10 minutes, something like that. Next says that Jada walks to school. The function d gives her distance again. Which equation tells us that Jada is 600 meters from school after 5 minutes? Go ahead and select your answer. This one is multiple choice. And finally, the news website shows a scatter plot with a positive relationship between the number of vending machines and the percentage of students who are absent. The headline reads, "Vending machines are causing our youth to miss school." What is wrong with this claim? So I put a little reminder down here. What is a scatter plot? It identifies a possible relationship between two changes observed in two sets of variables. It provides a visual statistical means to test the strength of the relationship. So what is wrong with this overall claim? This claim is saying that it caused our youth to miss school. A scatter plot shows a relationship, but it does not say what the cause of something is. So why are vending machines having a positive relationship with students being absent? It doesn't explain that. And so that's what the headline should say. We see there is a relationship between vending machines and absences, but we would need to research further to see why. We can't just say that the vending machines are causing the absences. We would need to see why that is happening.